All right, good morning, guys. This is an additional rule to Le Chatelier's principle. So to make sure I didn't overwhelm you guys with tons of stuff on Le Chatelier's principle in the last video, I sort of cut it short. And this one, I'm going to cut out the do now. We're going to cut out the exit slip. We're just going to add this additional rule here for Le Chatelier's principle. So Le Chatelier's principle from the other video, we talked about what would happen if you increase or decrease the concentration of something in an equation. How would that affect equilibrium? And we also talked about what would happen if you increased or decreased temperature and how that would affect equilibrium. And both of those were grouped together because they use that sort of seesaw analogy. You know, if you add or remove reactants or products, or if you add or remove heat, it sort of has this seesaw effect where it causes a shift, in which case the reaction has to shift in one way or the other. So I kept those together. This additional rule is going to deal with not concentration, not temperature. It's going to deal with pressure. So what happens when you change the pressure of a system or a reaction that includes gases? What happens to equilibrium? And it does not use the same sort of analogy with the seesaw. It has a different way of answering the question, and I wanted to go over it separately. So to make sure I didn't overwhelm you guys, like I said, it's just the rule. There's no exit slip. There's no do now. So we're going to jump right into it. All right. The rule is pretty straightforward. Increasing the pressure of a reaction at equilibrium will favor the side with fewer moles. And decreasing the pressure of a system that's at equilibrium will favor the side with more moles. So I'm going to pause the video. I'm going to ask you to do the same and copy down this rule for pressure. So copy this down now. Okay, so you know the rule. If you have a reaction and it's all at equilibrium and you increase the pressure, the reaction is going to shift towards the side with fewer moles. And the opposite's the truth. If you have a reaction at equilibrium and you decrease the pressure, it's going to shift to the side with more moles. So when you determine the number of moles in a chemical equation, you're going to use the coefficients. So essentially all you have to do is add up the numbers for the coefficients on the left side and the right side of the reaction and determine which side has more or less moles, and then you adjust it accordingly, depending on whether you're increasing or decreasing the pressure. So let me show you what I mean. Let's look at this equation. You've seen this one a bunch. I use the same equations a lot because it makes it easier to produce these slides and to make more copies of these questions to practice. So in this case, you have a reaction at equilibrium. Pop quiz. I'm going to pause the video here. Is this endothermic or exothermic? Take a minute, think about it. All right, so quick thing. If you remembered from earlier videos, heat is a reactant. That would tell me that it is a positive delta H. If it's a positive delta H, that tells me it's endothermic. Okay, so this is an endothermic reaction. Now, that won't be important for questions on pressure. Anyway, let's apply what we've just learned and let's determine what happens if we decrease the pressure. Okay, so I'm going to erase the stuff above here that was not important. That was just a bit of a review. So now, according to the rule, if you decrease the pressure, it's going to favor the side with more moles. So the reaction is going to favor the side with more moles. So we need to go determine how many moles are on each side, and we know it's going to favor the side with more moles. So decrease the pressure, it's going to favor the side with more moles. I'm going to write that down. More moles. Okay, so now he's got to determine which side has more moles, which side has fewer moles, and we're going to shift to the side with more moles. Pretty straightforward. Okay, once you make this first connection, these questions are easy. Okay, I don't think a lot of students actually make that connection. They forget the rule, and then they don't know where to begin. But we know that decreasing the pressure will favor the side with more moles. Well, I have two sides here. I got my reactant side and I got my product side. My reactant side only has one substance. The heat doesn't count for this. The heat is just a value of energy. When I'm talking about moles, we're talking about how much matter we have. So in this case, I have 2 moles on the left. So we got 2 moles on the left side. Okay, and on the right side, I guess I'll do that in a different color so to make it sort of stand out. We'll switch off from red and we'll go to green. I have 3 moles of hydrogen, and I have, don't forget about this, guys, sometimes this will matter. That invisible 1 is there. I actually have 1 mole of nitrogen. So I have 3 moles of H2 and 1 mole of N2. I have a total of 4 moles on the right. Okay, 4 moles. I'm just going to write it like MOL. Okay. All right. So I got 2 moles on the left and I got 4 moles on the right. We just used the rule. A decrease in pressure will favor the side with more moles. And that's another thing that gets students tripped up. What does it mean to favor the side with more moles? Well, this is where there's a little bit of overlap from the lesson from before. It's going to favor the side with more moles, meaning it's going to shift towards the right. Okay? So it's going to favor the side with more moles. In this case, the reaction is going to shift from left to right. Okay, so what happens if we decrease the pressure of the reaction? So use what you did from the last lesson on Le Chatelier's principle. The reaction will shift from the left to the right. And once you know that it's shifting from the left to the right, my concentrations of my products will go up because it's going to favor that side. It's going to make more product. And the concentrations of my reactants will go down. So what you'll say is, what happens if you decrease the pressure of the reaction? The amount of NH3 will decrease. The amount of H2 and N2 will increase. And that's all you have to do. All right, let's try another one. Okay, the opposite. It's the same equation. Nothing else is the same, or nothing else has changed, excuse me, except now we are going to increase the pressure. Okay, so what happens if you increase the pressure? Again, go back to your rule. An increase in pressure favors the side with fewer moles. So we're going to favor the side with fewer moles. I'm going to write that down here. So an increase in pressure favors the side with fewer moles. Okay? Fewer moles. So we're going to go to the side that has fewer moles. Again, it's that connection to the principle. It's the connection to the rule that you have to make first. And once you do that, once you make that connection, these questions are not terribly complex, but the initial ability to say, oh, this question is asking me to go learn that rule or to use that rule. Now I have to apply that rule. It's that initial connection that can be more difficult. All right, just like before, okay, you have 2 moles on the left and you have 4 moles on the right. Don't forget about that invisible 1. So we got 4 moles here versus only 2 moles here. So if we're increasing the pressure, this whole reaction here, this whole reaction is going to favor the side that has fewer moles. Well, the left side has fewer moles. So this reaction is going to actually shift back to the left. So if you increase the pressure, the reaction will shift to the left. Now, if it shifts to the left, we're going to make more reactants. The concentration of NH3 will increase because we're making more of it as the reaction shifts to the left. And the concentrations of H2 and N2 will decrease because we are making, we're using it up to make more of the reactants. So my product's concentration will decrease. My reactant concentration will increase. All right? I'll try 2 more for you guys on your own, and then we're done. All right, so let's look at a new reaction. We have the decomposition of water to form hydrogen and oxygen as our forward reaction, and the synthesis of water from hydrogen and oxygen is our reverse reaction. Again, pop quiz, pause the video. Is this endothermic and exothermic? What would the sign be of delta H? Think about it. All right, so again, now you notice that heat is a product. And when heat is a product, that means it's a negative delta H. And if it's a negative delta H, that is going to be exothermic. Okay, so negative delta H when heat is a product is exothermic. Actually, as I recall, we haven't even done delta H yet. I'm just getting so mixed up and doing these videos out of order. You will see the sign of delta H in a video later this week. Okay, but you do know that when heat is a product, it's exothermic. And when heat is a reactant, it's endothermic. So keep that in mind. All right, back to the actual extension here on Le Chatelier's principle. What happens if we change the pressure here? So you guys should know if you decrease the pressure, it's going to favor the side with more moles. Okay, it's going to favor the side with more moles. Well, in this case, I'm going to change color here again. We'll go to yellow. I have 2 moles on the reactant side. So I got 2 moles on this side. Then I got 2 plus 1. I have 3 moles on the product side. Okay, so I got 3 moles here. So what happens if you decrease the pressure? It's going to favor the side with more moles. So this reaction is going to favor this side. It's going to shift to the right to favor the side with more combined moles. So what happens if you decrease the pressure of the reaction? The concentrations of H2 and O2 will increase. Okay, and the concentration of water, H2O, will decrease. The amount of water you have will decrease because you're using this up to shift to the right to make more of these guys. All right? All right, one more really fast one. We'll look at the opposite case scenario. Again, it's the same reaction. If you increase the pressure, it's going to favor the side with fewer moles. Again, you have 2 moles on the left. You have the 3 moles on the right. So an increase in pressure will favor the side with fewer moles, and the side with fewer moles is the left side. So this reaction is going to shift back to the left. And therefore, the concentrations of H2 and O2, you're going to use those up as you make more H2O, and therefore the concentration of H2O will increase. Okay, so when these questions ask you what will happen if you make this change, you should always think about it in 2 parts. Which direction will it shift, and what will happen to the concentrations of reactants, and what will happen to the concentrations of products? And in this case, the reaction will shift to the left. You will use these guys up to do that, and therefore their concentration will go down. And as you use these guys up, they're being used up to make more of this. And so this concentration will increase. All right, so the reaction will shift to the left. The concentration of H2O will go up, and the concentrations of H2 and O2 will go down. All right? All right, super fast, quick review while we're here. What happens if you increase the temperature? Pause the video, think about it. I'm not even going to pause the video. I'm just going to buy you some time to think here. What would happen if you increase the temperature of the reaction? Pause it, solve it, and see if you're right. So here we go. All right, now you know that we're causing a change in temperature. That is a seesaw type based question. Temperature and concentration uses the seesaw analogy. So we're going to go back and do that review from the earlier lesson on Le Chatelier's principle. So there's my sort of middle of the seesaw, and here's my seesaw at equilibrium, right? It's all level. Now we're going to change it by adding temperature. And in this case, temperature is on this side of the equation. So when you increase the amount of temperature, you are increasing the heat. So we're going to add more heat, and heat is on that side of the seesaw. So what's going to happen to this seesaw? I'm going to do it in a different color. Do it in green. When you add more heat to this equation, it's going to get heavier on the side that has heat. So the seesaw is going to get out of whack like this. So there's your seesaw now. It's not even anymore. It got heavier on this side. What has to happen to get it back to, let's see if I'm getting it right, to get it back to level? It's got to shift back to the left. So what happens? The reaction has to shift to the left. The concentration of H2O will increase, and the concentrations of H2 and O2 will decrease. That is the full idea here. All right? All right. Let's go through this last one as review while we're all together. No, done. What happens if you decrease the concentration of N2 in the reaction vessel? Pause the video. Let's see if you guys got this. All right, let me go back to, we can use green again, sure. Again, now you see that we're dealing with concentration. Concentration and temperature, they do use that seesaw analogy, so you're gonna need to set that up. So you know you have to use the seesaw. Put your middle of your seesaw here, your fulcrum, okay? And you make your seesaw nice and level as I can. Now, if you decrease the concentration of N2, well, where is N2? It's on this side. So if you decrease the amount, that means you're making it, it's like you're taking some N2 out of there. You're removing it. So imagine if N2 were to like jump off the seesaw, suddenly now it would be heavier on the left. So the left side's actually going to go down. When you take away something on this side, it will make it lighter, and this side will actually go up. So it's going to go like this. Your seesaw is going to get out of whack like that by removing this N2. So what's going to have to happen here is this reaction is going to have to shift back to the right. Okay? So if this reaction shifts to the right, you are going to make more H2 and more N2, which means those concentrations will increase, and you're going to be using up NH3, and NH3's concentration will go down. So what happens if you decrease the concentration of N2? The reaction will shift to the right. You will make more H2 and more N2, and you will have to use up NH3. So these concentrations will actually increase, and this concentration will decrease. One little side note here as a real-world connection. This is a super common practice in companies that make chemicals. When you are trying to design a chemical, let's say the product of your chemical reaction is something that's very valuable. One thing you can do to make as much of it as possible is as you make it, you remove it from the reaction vessel. It's a very common method. So what happens is because you're removing the product from the reaction container as you keep making it, the reaction keeps shifting back towards that way to make more of it. So by removing a product and constantly decreasing its concentration in the reaction vessel, the reaction will be pushed to make more of that product. So if this is a valuable product, and in this case, if let's pretend that nitrogen was some valuable chemical, if you keep removing it from this reaction as you make it, the reaction is going to keep shifting to the right to make more of it to replace it. So you can keep taking it out and bottling it up and saving it, and the reaction will be pushed to the limits to go to the right here to make as much of that product as you possibly can. So this is a very common practice used by a lot of like industrial chemical production facilities. All right, anyway, side note, over. That's your micro lesson on Le Chatelier's principle for pressure. Now that goes along with concentration, goes along with temperature, and now you have pressure. Those are the three factors that we can change, and you'll have to be able to describe what will happen in terms of concentration of reactants and products when you make a change to something at equilibrium. All right, guys, that's the micro lesson. I will add this alongside of the other video for Le Chatelier's principle. Hope you guys have a great day.